This is the ROS Developers Podcast, episode 92.
The ROS Developers Podcast. The ROS Developers. The ROS Developers Podcast. The ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that give you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all of you that are using simulations when you are preparing your code for your robots. Yes, that's the correct way of doing it. You have to test first on the simulation, and once everything is working on the simulation, you can move into the real robot. Yeah, I know. It's not that fun, that funny. I mean, it's a little bit less funny. And you have to do a lot of work for that. But that's the proper way of doing it, the professional way of doing it. Otherwise, you can break your robot with your untested program, you know? So if you are using simulations when testing your code for the robots, this episode is dedicated to you. And today we are going to talk about how to do simulations for ROS using Unity. That's a very interesting subject, right? But before going into that, let me tell you a little bit about the academy that we have created, which is The Construct. It's an online academy where you can learn about the different subjects of ROS, from the beginners subjects into more professional ones like robotics subjects, different theoretical robotics subjects, also the basics of programming for robotics, ROS2, etc. And remember that we have added also a live robot lab where you can connect to the robots remotely from your place and practice on the real robots. These are real robots right now. Let me let me refresh this one because I think this page has been, you can see that this is the local time here in Barcelona while we are recording the episode. For the people on the podcast that are not watching the images, don't worry. It's just that I'm showing here the remote lab, and you can see the two robots that we have, one wheel robot and another arm robot. And you can control both of them from your home while practicing and learning a lot of ROS. I will put a link into the description below of this video so you can check later. Great. And now it's time that we go and talk with our guest today. And let me introduce you with Sarah Gibson, who is Senior Engineer Manager in Robotics at Unity Technologies. And she's going to talk with us, with me especially, about using Unity in robotics development, and especially on using ROS and Unity to build ROS-based robot simulations. Welcome to the podcast, Sarah.
Thank you, Ricardo. Thanks for having me.
My pleasure. And then I think that the first question that I have to ask you is, what is Unity? Because maybe some people, the robotics developers, they don't know that, even if it's strange. But can you tell us what is Unity?
Yeah, sure. So Unity is a platform for creating and operating real-time 3D content. And Unity actually started out as a game, but then that turned into a complete game engine, which is probably what most of your listeners think of when they think of Unity. But now you can use the platform not just for games, but also developing any type of AR, VR across many different industries. So think manufacturing, engineering, construction, architecture, media and entertainment. Lots of people get to use Unity. And now also for industrial simulations, including robotic simulations, which is what we're here to talk about today.
Okay, great. Yes, I think that most of the audience will be familiar with the engine of Unity. And Yeah, I didn't know actually that it started as a game, initially as a game, and that is awesome. Then as an engine, then it can be used in all those different industries and processes that you have mentioned very well. And then what is interesting? Why Unity could be used in robotics?
So as you correctly said at the beginning of the show, simulation is a really important part when you're developing robots in an industrial context, but it's also really important when you're teaching and learning robotics from the educational context. I myself learned how to use ROS through simulation. And so as a game engine, the Unity runtime is fundamentally made up of the same components as robotic simulators. Namely, you have a rendering engine and a physics engine, and both of which have undergone years of development and optimization at Unity. Plus, we have a really great authoring tool called the Unity Editor. So it's basically everything that you need to start writing and executing robotic simulations.
Okay, that's nice. When you said the editor, then I think that my eyes go like this, because we are used to create simulations for robots by typing code. That is terrible. That is terrible. And then you do a single mistake, and then one letter gets out, and then the simulation doesn't load, just fails, and then you have to find that error there. It's a nightmare. So Unity provides the editor that I presume is the editor that the game creators are using to build their worlds.
Exactly.
Okay.
Yeah.
Okay. And okay. So and what about so let's say we can use those, we can create those worlds for a simulation, but here we are talking about ROS. So this is the ROS Developers Podcast. Then how does this integrate with ROS, those simulations?
Right. So last year, we released a couple of open source packages on the Unity Robotics Hub, which is our GitHub page, for integrating Unity with ROS1 applications. So this includes a Unity package that you install in your Unity project, as well as a ROS package that you have to build in your Catkin workspace. And this allows you to set up publishers, subscribers, and services that pass messages between Unity and your ROS1 nodes.
Okay. Okay.
Yeah.
So, and that is all that we need in order to have Unity simulation working with with ROS.
Correct.
Okay. In terms of installation and so on. So now we need something else because we need to create the simulations, the actual simulations, right? And then, so the first question is, can we load our Gazebo simulations into Unity, or we have to create the simulations from scratch?
Yeah, we don't support importing the Gazebo world files yet. So we encourage you to take the path of creating the environment through the editor. But there's, Unity has a really large developer community and asset store that you can use to help bootstrap your environment creation. So you may not need to really start from scratch. And there's lots of tutorials available on learn.unity.com to help you get started. All of those are free. And also, since the developer community is so large, you can actually find a lot of really good resources even on YouTube, which is how I learned some of the basic Unity concepts.
Okay. So two questions. But first, one before. You mentioned that you have learned ROS by using simulations. Would it be possible that you use our academy for that or not? No. Okay. Not. Okay.
I think that was maybe before the academy.
Okay. Just curious. I thought about the question before, but I forgot when you mentioned about that. Okay. Anyway, so the question is about the world files. Okay. We are talking here about the world files, the environment in which our robots are going to be moving and interacting. And then that means that I can actually buy or download it. Somebody has put it for free. One of those worlds that already exist, like for example, like a warehouse, and then it's already made actually. That
exactly.
super complex environment. So I don't have to do anything. Just download that, and that's it.
Yeah, certainly to get started, you could download an already existing world file. You may want to eventually customize it to your
Yeah,
specific use case, but that's, a more advanced topic that you could get into later.
later, exactly. Okay,
Yeah.
okay. That's cool. That's cool because I have seen some amazing environments there on the store. Which wow, for testing things of robotics, they are very very cool, very cool. But then we move into the robot importing. You know, because in ROS it's very important to have the URDF model. And then, so can we, if we have the URDF model of our robot, can we import this into the Unity world?
Yes. If you have a URDF model already, then perfect, you're in luck. You can use our URDF importer package, which is another Unity package available on Unity Robotics Hub, for free, open source on GitHub. You just install that package in your Unity project, and then you click a button to install or to import your robot, and it creates all of the game objects in Unity for you, along with some low-level controllers that call the physics API for moving the robot. So we try to make that part easy for you.
Okay, okay, great. Let me see my questions that I don't forget any. And then, yeah, so then what about the sensors? So which sensors are supported in Unity?
So we're partnering closely with another team at Unity who is building something called Sensor SDK, which is a way to do physically based sensor modeling in Unity. So they're very, very accurate sensor models. And they're currently in beta and taking signups for early access to that program. But the sensors that they support now are RGB cameras, RGBD cameras, and LiDAR. But that sensor SDK package also allows you to create your own custom sensors within the SDK if you want to do something different.
Okay, and okay, I will put a link on the show notes here of the program of this episode, so people can access to the SDK and also to all the other resources that you mentioned before. Okay, so you can mention in this without any problem. They will find it on the show notes, and then so by using this SDK for creating the plugins for the different sensors, then can we access that data from a ROS program? So how does it works? How does it work?
Yeah, so right now, when you're generating sensor data in Unity, that sensor data is, staying within the Unity world. So if you wanted to get it out to ROS, all you would need to do is install the ROS Unity plugin, which is called ROS TCP connector. And then you can set up a publisher inside Unity to take that data that the sensor is generating and publish it to whatever ROS topic you want to send it to.
Okay. Then let me put a little bit the whole picture. So the whole picture now would be, so I have a wall file that describes the wall. It's a Unity file that has there. Then I have imported my URDF model that I created for ROS. And then I have the robot inside that wall at some point. Then I have those sensor plugins that I have attached to the sensors of my robot. And then I have this package, ROS Unity package, that is connecting to the sensor data and publishing into a topic that is the one that I will have in Gazebo simulation. Sorry to compare to Gazebo, but it's because it's a standard and it comes with ROS, and then everybody understands that.
Yeah, you got it. You described it perfectly.
Okay. And then from that point, then any person can have his program and, for example, start doing a map, creating a map, or navigating on this area, avoid the obstacles, and so on. Okay, great. And let me see. Then about the actuators. So which kind of actuators are provided in Unity?
Yeah, okay. So in Unity, you can choose to model your robot at various different levels of abstraction, like in any simulator. So for example, let's say you want to control a wheeled robot like a turtlebot. You would probably want to give it a twist command from your robot, from your ROS application. So in Unity, we provide that low-level physics interface that translates the twist command into target velocities for the robot links.
Okay.
So similarly for the industrial robot arms, we have an interface for setting either the target position or target velocity of each joint. Also, you could apply a torque directly. And so these are similar to the interfaces, the hardware interfaces in the ROS control package, if you're familiar with those. If you actually wanted to model have a higher fidelity model of specific actuators, like specific motors, you could also do that from a tool that our partner team is developing called System Graph. And they just released a blog on the Unity blog describing their partnership with Velodyne, who's using Unity to model LiDAR sensors inside Unity. And they explain how they actually have a model of the actual motor that's rotating the sensor, which they built in System Graph in Unity. So you have different options depending on what you care about modeling.
Okay. Okay. Yeah. So then, so far, if I have understood, then we can model wheels. For that, then we have a differential drive plugin, maybe, or is each wheel separately controlled?
The way that we have been doing it on my team is just if you have like a turtle bot with wheels, we model that as an articulation body chain. And so we just use the articulation body APIs, which is to set target velocities of the wheels. I have seen some packages on the asset store for differential drive, so you could try that out too, but I haven't tried those myself yet.
Okay, okay. Maybe we'll have a try of this and then maybe publish some results, because I think it's quite interesting to provide this, like how it works directly in a video in YouTube. So I will let you know when we have that. Okay. And then let me see. Okay, so we talk about here about the URDF model, and then another thing about the simulation is that one of the missing things in Gazebo that everybody's asking us, it's about the simulation of humans. Because people want to simulate an environment where there is people moving around, and maybe the robot has to follow them or avoid them or so. So how it is handled, the simulation of humans in Unity?
Yeah, that's a super interesting problem and use case, because coming up a lot with collaborative robots and cobots and that kind of thing. So it's modeling humans and their behavior is actually a really common task in game development, as you can imagine. It's called character animation. And there's lots of assets and resources online to help you get started with this. But basically how it works is you would add your human characters to the Unity project, along with what are called animator components and controller scripts, which control the behavior. And then there's different animation modes or update modes for the characters. But if you select one that's called animate physics, then the character animation is actually part of the physics update loop of the simulator. And so it would physically interact with any other physics components that you have in the scene, like the robot or other rigid body objects or articulation body objects.
Or a sensor. So if it is included inside the loop, then the laser will detect the legs, for example, of the person, right? And as it moves, then it will be detecting. Okay.
Yeah.
That's very cool, because this is something that has been missed in Gazebo. In the latest versions, there is the possibility to do that, but to a limited extent. So nothing compared to what we see in the games, of course. And then that's cool. I was especially interested on this physics update loop that you mentioned, because one thing is to see the object there, and another thing is that it really interacts with the physics. That's something different.
Yeah.
Okay. And then talking about the physics then, so which physics engine is using Unity?
So the default physics engine in Unity is NVIDIA PhysX. And last year we upgraded the physics engine to PhysX 4.1, which has a bunch of new features that makes robotic simulations more accurate. So for example, that's how we got the articulation bodies, which I mentioned earlier, and also a new solver, which allows you to run more physically realistic simulations of robot arms and other kinematic chains. And so with this, for example, you can simulate grasping a robot arm grasping rigid objects, and we have a demo of that on the Unity Robotics Hub.
Uh-huh. Okay, and the grasping is a very complex thing in simulation. So then you are mentioning, you are saying that then in Unity it is possible to do a grasping, for example, of this nice Mac for sale in our shop, by the way. So you can grasp this, and then depending on what it is inside, then maybe the robot can pull it up, move it up or not. Is that? So
Yes.
Okay. Okay. Yeah. Okay. So I'm very interested to see those demonstrations, because that's a very complex system. Even in Gazebo is a little bit difficult to get it right because of the computation of the contact forces on the surface, and avoiding to get inside the object. You know, by in the inside, I mean, in the simulation, you have to the contact points that doesn't mix together the hand with the other.
Yeah, you have to get your collision boxes right. That's for sure.
Yes, exactly. And the computation is important, because it depends on the step that you have and of computing the physics, and then it can happen that at the end your finger is in one step, the finger is outside is not colliding yet, and then on the next step the finger is already inside the object. So you have to manage this properly.
Yes, and we have a few physics features that help with that. One is that, of course, you can change the simulation step size in physics. And we also have some different collision detection modes that we describe them on our webpage on Unity Robotics Hub, but we have something called continuous collision detection that may help with that.
Okay, and then when you integrate, I think that this is the correct way of going it, but then so what happens with the performance of the system? Because in the games, when we see the games, so the games, they are using a lot of tricks to avoid computation of physics. But then when you start to require to have those kinds of detailed physics, then what is happening with the performance?
Well, of course, if you want to have a smaller simulation step size, it's going to slow down the simulation. So that's a trade-off that you can, make for yourself. It depends on your application as far as how fast or slow you need to run. But generally, PhysX is really optimized, for games that need to be real time. And so it has a pretty good speed accuracy trade-off compared to other simulators.
Yeah, I think it's based on the multi-threading, so it can actually split the physics. I'm not an expert on that, but as far as I know, I would like you to confirm with you. So it can split the computation of physics between different threads, so it can actually perform complex computations of physics in the same amount of time, provided that you have enough cores for that. Am I right?
I'm actually not an expert on that one either.
Okay. But
I can follow up.
Okay. Then I think that Physics X is multi-threading in the computation of physics, and that allows the physics engine to distribute the computation of multiple things. Let's say different elements in the scene, like it's not only this hand, but another hand, and then both hands, they are doing a collision, and each one of those, it's performing different threads of the computer, which in Gazebo, this is not possible at present, as far as I know. So if anybody in the audience knows more about this subject and can enlighten us, please put it on the comments of this interview. Okay, then let me see my question. So, yeah, so now ROS, ROS in space. So it's now a fashion subject because NASA has announced that they are going to use ROS2 in the next rover that they are going to send to the moon. So ROS is going to be on the moon. People there, if you are creating code, is your chance to get your code now into the moon. So now contribute to ROS2, and then maybe you will have the chance that your code it's going to be run on the moon. So go for it. Contribute to ROS2, okay? Okay, so now the question for Sarah. Sorry for making you wait there. Then the question is, so what about the possibilities of using Unity for simulating this kind of environments like robots on space?
So I think testing a space robot is obviously an excellent case for simulation because that's probably the hardest real world test environment to set up, in the real world to make it similar to the environment on the moon or Mars with different gravitational fields and different atmospheres and air pressures and everything. So this is a great case for using Unity. So in Unity, for example, you can change gravity. Changing gravity is as simple as just changing that parameter in the physics settings. Also, I'm glad that you brought up ROS2 because when I mentioned our integration with ROS earlier, I mentioned that we have a package for connecting Unity to ROS1 applications. Well, we're also working on our package for integrating with ROS2 applications. It's currently in alpha, so we're taking signups for customers who want early access to the program. You can sign up on Unity Robotics Hub. And we're hoping that will come out as a generally available package later this year.
Okay. Okay, then you mentioned about modifying the conditions of gravity, for example, and then so do you have any demo of that it's in any video or something like that I can you think of any? No.
I don't know that we have any public videos. We have done some experiments internally. With,
okay.
simulating a Mars rover and that kind of thing.
Okay, I'm asking you that because I was talking last week with Alison Thaxton, who is, I don't know, you know her, and she is a...
I've heard her talk.
Yeah, okay, yeah, exactly. So about ROS in space. Yeah, so she was explaining to me about the difference in doing a grasp in space and here on Earth, because on Earth, if you miss the grasp for something for, let's say, 1 centimeter, then still the collision, okay, like with this, the collision is going to allow you to grasp the object properly. But in the space, because there is no friction, so if you miss and then you collide, then the object is going to go away. So your grasp is going to fail, for example.
Interesting.
So so I would like to see if anybody in the audience has done this kind of simulations using Unity, and you can also tell us and report to all the rest of the audience and see how those results are happening. I think it's very, very interesting to do that. And we are talking about the space, but what about underwater robotics?
Yeah, so that's also a really interesting problem. Our native physics engine, PhysX 4.1, doesn't support fluid dynamics or aerodynamics at the physics layer, but you can do a lot of that at the scripting layer, some high-level models. This is similar to the approach that AirSim takes to simulate air vehicles. And by the way, I don't know if you know, but there's also a version of AirSim for Unity.
Okay, no, I didn't know. That's awesome. So
yeah,
but wait a second. Is this been released recently or?
I think it was a couple of years ago.
Okay, so I thought that we had a breaking news now here, but
no.
It's not. Okay, okay.
And the other thing about underwater and air vehicles, You can also try out this physics engine called AGX Dynamics, which is a physics engine that we released through one of our verified solution partners. It's a very accurate physics engine that's specifically designed for industry grade multi-body simulations, and they have a plugin for Unity. So they have some really cool demos on their website. And I bring this up because they have a module for hydrodynamics and wind also. So that would be something to look into if you want to simulate water and air dynamics at the physics layer.
Okay, so we can use this second physics engine instead of PhysX. So
Right.
you can replace one by the other, and then get this benefit of extra. Okay, great. What's the name again? Can you tell me of this?
It's called AGX Dynamics.
Okay, AGX Dynamics. Okay, great.
And actually, you can really swap in any physics engine that you want. I mean, that's possible. So, for example, there's a plugin for using the Bullet physics engine in Unity. So people have made different plugins for different physics engines. So that's always an option too.
Ah, okay, that's awesome. Yeah, the Bullet is being used as in several humanoid robots to simulate, because the dynamics, it's I understand that is better for that case with the Bullet physics engine.
It's a good physics engine.
Okay, and I think that there is also a plugin for this in Gazebo for this.
I think so. Yeah.
Okay. Very good. Okay, so far, we can use the physics X, but then we can substitute this one with another one, the one that you mentioned that I forgot the name, but I will put the link on the show notes, and then also Bullet, which is also supported by default, the plugin, and any other can be integrated if somebody needs it.
Yeah, if you want to do the work to integrate it, then have at it.
Okay, maybe it could be a Google Summer Code project or something like that. Could be.
Yeah, sure.
Yes. Okay, then let me see. Okay, one very, very important question for the ROS community. This question is very important. So what about the paying model? How does it work? So if I want to create a simulation, or if I want to use a simulation that somebody has created, so do I have to pay?
Okay, great question. We get this question a lot, so I'm happy to answer it. First of all, we operate on a licensing model for the Unity editor. So what that means is that you have to have a license to use the editor to author your scenes and simulations. But once you create a simulation, which we call the player build, which is basically a binary file, you can use and distribute that freely. So it's similar to the Photoshop model where you pay to use the tool, but the art that you create with it is yours to do with it whatever you want. Okay, so now about the licensing model for the editor. You can see all of the plans on our website, but we offer a personal version, which is completely free as long as your revenue or funding is less than 100,000 US dollars per year. So this is a great option for students and other beginners who want to try it out. Beyond that, if you're a big company who's using it as part of your everyday workflow, we have plans like Plus, Pro, and Enterprise options. All of them are at different price points and include different feature sets. And again, you can find all of that information laid out in a nice table on the Unity website.
Okay, and I will put a link also on the show notes about that. Yeah, because I mean, it's important. But basically, I think that the most important question is that a lot of ROS developers, that they are just individuals, that's the majority of the people, of the ROS developers. They are studying, they are learning because they want to improve their skills and so on. So basically, for them, it's for free. So they can use the editor to create it. And once they have created those worlds, whoever who uses the worlds doesn't have to pay anything, because it's just the usage of this binary running right?
That's right.
Okay, great. Then audience, go there and create super cool walls that we can use. Okay, so that's a call. And what about, let me see. So that's clear. Then let me go to the final question. It is the best one. I don't know what is going to happen with the audience. So why should we use Unity instead of Gazebo? Fight.
Okay. So Unity is no, sorry. I was going to say Gazebo is a great tool, I have to say. And like when I say that I learned how to I learned about robotics through simulation, for me that was with Gazebo. But I think for serious industrial robotics customers, there's a lot of reasons to choose Unity over Gazebo. One is that we have better rendering, more photorealism. So if your application that you're developing requires photorealism, then Unity would be a better option. And we didn't touch on this yet, but we have also, we work closely with a partner team called the computer vision team, who is developing lots of really cool computer vision packages. One of them is called the perception package, and we have a link to it from Unity Robotics Hub, but this allows you to generate large amounts of synthetic labeled training data with domain randomization, which could be of interest to you if you want to use machine learning for your vision model on your robot. So basically anything where if you need photorealism or high fidelity rendering, Unity is a great option for you. Also, like we touched on this before, but Unity has had years of optimizations for running real-time games, and that makes it more performant in most cases. So Unity scales better to larger and more complex environments. And also, I think we offer a better authoring experience. As I mentioned before, we have more community assets to draw upon, which should make environment creation easier. And also, Unity is supported on multiple platforms, Linux, Windows, and Mac.
Okay, great. Great. And let me tell you another one that is related to one of the options that you mentioned. It's about creating big simulations. I mean, in a large wall, because at present with Gazebo we are restricted on the size, because the larger the space that you simulate, it's going slow and very, very slow, and the more assets you put inside the simulation, it goes slow. In Unity, in my experience, because of this multi-threading of the physics engine, as long as you put more computers, then you can keep adding more assets and more stuff and larger worlds, and then the performance doesn't get so much disturbed. So that's in my experience and what I have tested and so on. So that's very interesting, because this is one of the limitations that we are suffering in robotics, the creation of a large thing, like, let's say, like a complex shopping mall with several stages and many people moving around and so on. Okay, great. So, well, I think that that's the final conclusion about why you need to use Unity instead of Gazebo, and it's quite fair. So, thank you very much, Sarah, for coming here and explaining us your projects about using Unity with ROS. Thank you.
Thank you, Ricardo.
Okay, and for all the audience, so that's the end of the episode. Please, I would like to know your feedback. What do you think about the podcast? Send me a message. Come on. Tell me on the comments below, what do you think? If you would like to have somebody special on the podcast, give me a suggestion. And of course, put us 5 stars in all the platforms that you are listening to this podcast, okay? So thank you very much, everyone. See you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.